On slide 37, we will be going deeper into multi-level factor analysis and see where it can take us into new kinds of analyses. So we have the standard multi-level setting here with a prototypical example of students observed within schools. So we have a random intercept for each of the factor indicators, the student level factor indicators. Those random intercepts then become continuous latent variables on the school level, and those continuous latent variables are indicators of a between level factor, which could be seen as school excellence or something of the kind. So this is a cross-sectional situation with students within schools or students within classrooms. So it's a hierarchical situation, students nested within schools. But the case of time points nested within individuals is also multi-level. So couldn't we apply this model also to longitudinal data? What would that look like? Well, I think then that multi-level factor modeling can actually teach us how to do longitudinal factor modeling, in this case for 2 time points. So here we have the cross-sectional model, and it's translated into a longitudinal model here, where at time point 1 we have a within factor, and time point 2 a within factor, and they are the same. We have the same factor loadings across time. We have the same residual variances across time, equality of those as well. And if you want to study change in factor means, you would have to have the same measurement intercepts across time as well. Now, on the between level then, if you go back up to the multi-level factor model, you have a random intercept for each factor indicator. And there are only 3 of them, so therefore there should be 3 circles here, like it is in the modeling up there, and with 1 factor behind them, and with residuals coming into those U random intercepts as well. And we have equality there as well across time, except that's a sort of a trivial equality because the influence from the U's to the U circles to the U boxes have coefficients 1. So these are all fixed 1, which is sort of an invisible connection here between the random intercepts and the U boxes. They are connected 1, so to speak. So this is then a longitudinal factor model, and if you analyze data in 2-level long format and translate it into single level wide format and analyzing this model with these equalities, you get exactly the same log likelihood and exactly the same maximum likelihood estimates. Just like we talked about on slide 13, where we discussed a random intercept logistic regression. Except there was a simple case of a univariate response, and now we have 3 response variables and not only 1 random intercept, but actually 3 random intercepts. Now what we cannot do in the multi-level setting here, in standard multi-level factor analysis settings, we can't have any relationship between FW1 and FW2. But once we have moved over to the wide format, we can have this influence. So the model is extended to include, in this case, an autoregression for the FW factors. And you actually have a residual arrow here as well. So that's an interesting longitudinal factor analysis model based on multi-level thinking, and a very rich model where you can tease out within and between sources of variation, where the between sources are now variation across subjects, across individuals, because level 2 is individual and level 1 is time. So this is the within the time factor analysis model. We'll say a little bit more about that in a while. Now, if you go back to the cross-sectional setting, what does this influence mean? What would that correspond to? Well, it corresponds to a model where students within schools or perhaps within classrooms influence each other. So you have one student here influencing another. So the students are the within units, right? So that could perhaps be applied in small group research where you have leaders influencing followers. Now, this multi-level-based longitudinal model is quite different from the naive longitudinal model, which uses only this bottom part typically, not this top part here with the random intercepts. Now, this actually was suggested in a paper that's by Hammaker and others in 2016 in MBR, but it sort of has fallen from the attention of most researchers. It's an argument for having multi-wave data, longitudinal data, to decide on factor analysis structures. It's directly based on the multi-level factor analysis model. It's inspired by that and directly translated into the longitudinal framework. And it was called the CUTS model, Common and Unique Traits and States, I think it translates to. So it argues that factors obtained from cross-sectional factor analysis are partly determined by between and partly by within-person covariance structure. And that's referring back to work by Cattell in 1978. And that blend of within and between sources is what Raudenbusch and Breich call an uninterpretable blend when you consider multi-level regression. Now, multi-level-based longitudinal factor analysis allows differences between, on the one hand, between-person trait-like factor structure, something that's more stable across time, and within-person state-like factor structure. So within-person state-like factor structure is what you have at the bottom of that model. 2 time points is sufficient to determine the within-person factor structure. Typically, you would have intensive longitudinal data to be able to estimate a factor model for each person. So we're talking here about n=1 analysis, or Cattell's P technique. So doing a factor analysis for each person where the number of observations then is the number of time points. Of course, then you would need long longitudinal data, which is called intensive longitudinal data. But this article argues that t=2, 2 time points, is sufficient to identify the model on the previous slide. Of course, if you have longer longitudinal data and analyze a group of individuals, you can learn more about your factor structure. And we'll talk about that in a few slides. So this kind of work goes back to work by Carl Jørskog and his longitudinal work with other regressive models, and Rafalovich, Bornstedt in Sociological Methods and Research, and Herb Marsh together with Grayson wrote about it in 1994 in the SEM journal. Actually, one of their models is identical to the so-called CUTS model in the Hammaker et al. Article. And I wrote about that in 1996, related models, and Domenici-Windel in MBR, and Geiser in Psychological Methods and in Behavioral Research. If you turn to slide 41 then, let's take an application of longitudinal factor analysis done in this multi-level factor analysis inspired modeling framework. So in the Domenici and Windel article, there's an example used also in the Hammaker et al. Article, depression in adolescence, where you consider t=4, 4 time points. And you have 4 items, 4 subscales of the CSD: depressed affect, positive affect, somatic complaints, interpersonal, and you specify one factor on both levels, on the within and the between. And then you can consider, for simplicity, just one fit comparison measure based on the information criterion BIC, which based on maximum likelihood and rewards models with high likelihood and relatively few parameters. And a low BIC is a good fit, better fit to the data. So for the naive model versus the multi-level-based model, both with AR1, autoregressive lag 1, and again, the naive model, going back to slide 39, is the model that only has the bottom part in it. So for the male sample, the BIC improves drastically from 26,000 down to 25,000. For females, from 32,000 to 31,000. That's quite a big improvement in the model fit. Now, also the naive model gives inflated reliabilities. So these are, one-factor models, and if you look at the standardized loadings, you can see what the reliabilities are going to be. You can square them, and that's compared to the naive model gives inflated reliabilities relative to what you get in the longitudinal factor analysis model based on multi-level modeling for the within factor. And it also gives inflated autoregressive coefficients, how factors depend on each other over time. Now the question is then, when we are in this rich longitudinal modeling framework based on the multi-level factor analysis model, we can be interested in various kinds of reliabilities. Reliability with respect to the within factor or the between factor, which is the trait factor, the more stable factor, or both, or some sort of combination of the two. Now, so one can think about this and ask the question, what then does longitudinal factor analysis, this longitudinal factor analysis that's based on multi-level factor analysis, what does it imply for cross-sectional factor analysis of a single time point? And what does it imply for latent class analysis? So what I did was I generated data from a longitudinal factor analysis model with within and between variation, and I analyzed one time point using what I call the regular naive factor analysis. So, for example, I used data generated by one between factor, but where the items had different loadings across indicators. I imagine, for instance, a model for anxiety and depression, where anxiety items have different loadings than depression items because they may vary across individuals differently, different amounts of variation as reflected by those loadings. So I have two sets of loadings for this one between factor. And then I have one within factor with equal loadings across the items. Now, regular factor analysis then would mistakenly settle on two factors. There is then a clear two-factor factor loading pattern. But the model that the data were generated by doesn't have variation across individuals in two factors, as the naive analysis says, but instead you have variation in one factor across individuals and variation in one factor across time. So one between factor, one within factor. But they're not two factors that vary across individuals. So you would get the wrong conclusion here. So that says essentially, to use a term from complex survey analysis, we're dealing with a non-aggregatable model. If you generate data by a multi-level factor analysis inspired longitudinal factor analysis model, it is not obviously clear, and most likely not the case, that you would find the same model if you analyze it, ignoring the between part as you would in the cross-sectional regular factor analysis. So this has been seen in other situations in cross-sectional multi-level settings. I wrote about it in 1989 in this paper, and also, together with Albus Artora, we wrote about it in the complex sample data setting. And you may want to take a look at those articles.